we have seen a coronal mass ejection, as well as the likelihood of major solar flares continue. And I'd like to dedicate this video to my granddad, Bob Carson, one of the best people I've ever met. Let's get into the daily space weather. So in the colorized magnetogram, we see some activity gaining here behind this North Pole umbra. You can see some magnetic field intensity forming there behind that umbra. And that could be an indication we're going to see some flaring from it. I would still say the likelihood of major solar flares is very high. And as Sunspot 2916 approaches the limb, the likelihood of it producing an M or X class flare is certainly not evaporating. It's mostly stable over the past 24. Here's 335 angstroms from the Solar Dynamics Observatory. Here's the northern hemisphere in that wavelength. Here's the south. Some filaments still hanging out down here in the southwest. Radio flux has dropped down to 111 solar flux units. There's the 1-year chart. The black line here is the radio flux. The red line is the sunspot number. You can see how proportional those are. Space Weather Enthusiast dashboard, not expecting any space weather storms or geomagnetic unrest in the next 3 days. There's your New Year's Day space weather forecast at the moment. This could change. Again, keep in mind there are some coronal mass ejections that have just occurred in the past 24 hours. We'll get to it later in the video. First, global seismicity. There was one major quake over the past 24. Smash Team members would have been notified about this. Join our email list at smashomash.com/smashteam. There are all kinds of perks that you can still get. Consider becoming a gold or silver or gold paid up annual subscriber. There's the largest quake of the past 24. It was a deep quake at 166 kilometers estimated depth. It was a 7.3 magnitude located at Timor-Leste, rather. And I didn't see any tsunami alerts on that one. I don't believe it generated one. It was at depth. So keep in mind, if that happened at the surface, that would be about an 8 magnitude earthquake. And of course, you'll see foreshocks. Quite a bit of quakes around the Pacific Rim there, some around the west coast of the U.S. as well. A 4.8 at nearly 600 kilometers occurred at Fiji. South Sandwich Islands region saw a 5.7. That continues to be one of the seismically most active points on the planet. Check this one out. This one occurring at 1,400 meters above sea level, although it was only a 2.6 magnitude. If we've left out any quakes on the list, just let us know in the comments. There was a 5.4 north of that 7.3. And let's take a look at volcanoes here. And starting out with some great thermal imagery here of a lava flow at Kilauea. So some continued new real estate gets created there in Hawaii. Shivaluch. Volcanic ash not identifiable in satellite imagery. And check it out, it's the cock's tail generated from the eruption at Hunga Tonga Hunga Ha'apai. Go ahead, say it. Hunga Tonga Hunga Ha'apai. Suwanosejima exploded, flight level 050. It's a 5,000-foot ash plume. So effusive eruptions occurring at Kilauea there. Again, new real estate being created on Hawaii. Hunga Tonga Hunga Ha'apai. Another explosive activity here. Rocket-like fragments. A reason not to be around erupting volcanoes. It could rain lava bombs on you, or even just rocks. Volcanoes, a bit of an interesting portion of the planet's crust, wouldn't you agree? Fuego exploding, flight level 150 from Fuego, that's located in Guatemala, 15,000-foot ash plume. Nevado del Ruiz, 19,000-foot ash plume over Colombia from explosive activity at Nevado del Ruiz. Revenador exploding, flight level 150 over Ecuador. and possible emissions at Sabancaya are a reminder not to pole vault the caldera. Here's a reminder to support the channel. One of the ways you can do it is by becoming a member of the Smash Team. SmashoMash.com/SmashTeam will hook you up with information nobody else gets to see on the internet. I won't provide any teasers besides that, and we'll continue putting up free publicly visible posts through the old year, thanks to our gold, silver, and gold paid up annual subscriptions. Another way to support the channel is by picking up merch, where we would remind you all to Mansa. It's completely apolitical. We're telling you to make America not suck again. Look around you. Does the area around you suck? Could you make it not suck while we encourage you to do so? You can take that however you like. It's up to you to make America not suck. And if you're relying on bureaucracies that can't even get out of their own way, as they stumble, bumble, and fumble, you may need to, if you're wondering who the cavalry is, it could be because you're the cavalry. Universum liberate. Make America not suck again. That is entirely apolitical. I've never been associated with a political party and likely never will be. You can find links to the merch below the video, as well as to SmashoMash.com and the Smash Team, links on the homepage. Welcome to the Neo-Renaissance. Let's continue on. Also, if you're shopping for a bike, it would help us out a lot if you considered me your personal cycling expert. I've been doing it a while, so if you're in the market for a bike, hit me up. Links below the video to that as well. We need your assistance to keep the videos. We need your assistance to keep the videos in existence here at the Smash News Network. Least busted name in news. Let's get to magnetic data. We saw some pretty high readings here happening around noontime, local time for the GOES 17 satellite, making it all the way up to 156 nanotesla there, around 2250 yesterday on the 29th. Since then, a coronal hole wind stream has arrived. We'll get to it. First, some views of the top view ecliptic plane field plot. Earth remains in a North Pole current sheet shown here in green. Here's the line of sight view. Solar activity's been dropping the past few days, and most of it's on the western side of the sun at the moment. No apparent new sunspots rising, but there are coronal holes. And there they are, also the sun's B field shown here, those blue potential field surface source lines. The sun's B field. That's the line of sight coronal hole plot. And let's take a ultraviolet view here. This is 193 angstroms from the SDO. And you can see that fairly well-defined North Pole-oriented coronal hole happening here. The solar corona is very bumpy. And this is one of the good views to see into that. That coronal hole there is what you'd call a trough in the corona. And let's look at sunspots. So this 1700 angstroms view, this will show all the sunspots. And these setting ones up here are still capable of producing M-class flares, I would say. Possibly even an X-class flare could come from that after it sets. So that group will lose its name today. The sunspot number is going to drop precipitously, but we'll still have a huge spike even in the monthly smooth numbers. Likelihood of major flares is still there, more likely than not, in my opinion, mainly from sunspot 2916, and it actually becomes more likely to produce major flares than less, in the opinions of many of us, as there seems to be a correlation with proximity to the limbs and major flare. In other words, we see less major flares around here than we do around this other circle. Major flares are more likely around the limb than they are around the center of the disk. Of course, they're more likely to send a coronal mass ejection toward Earth at the center of the disk. We won't worry about it. It's the daily space weather. Here's another close-up view. 94 angstroms is one of the best views, one of the best wavelengths to view solar flare activity. So if we do see a major flare, this will be one of the ones we'll probably cover. And again, the likelihood of major flares is quite high with those large sunspots, especially with the magnetic complexification. Complexification? Is that a word? I don't know. Anyway, there's the GOES X-ray flux over the past 3 days. You can see two M-class flares on there. And these sunspots have largely underperformed, so quite a few sunspots formed there, not a whole lot of flaring came out of them. And we use the field to determine whether or not they're likely to produce flares. No proton spikes, no relativistic particles sent from any of that activity. And the real-time solar wind's been recently elevated here. It looks like another coronal hole wind stream showed up. Here's the density spike, and we saw up to a pretty nominal coronal hole density spike there, just over 30 protons per cubic centimeter. And then you see a dip and a rise in the solar wind speed. So we're right around 500 kilometers per second right now for the solar wind speed, solar wind density around 6 protons per cubic centimeter, everything else fairly uneventful on the solar wind data. KP index at 3, that's a measurement of global geomagnetism. And let's take a look at Earth's geomagnetic moment from space for the past 4 hours. Looks like we see some minor variations happening here in the pressure. And the pressure is modeled here in the units of nanopascals, magnetohydrodynamic pressure. You're looking at about 12 Earth diameters, Earth's magnetic moment from space. Geospace magnetosphere movie showing pressure. And we'll let that play through there to get you a full 4-hour run. We show the data daily, so you don't have to look it up in one convenient video, tying together tons of facts and hopefully serving as a resource for those of you who understand heliophysics and geophysics and astrophysics and cosmology. Next, Earth's geomagnetic moment from the ground. The scale modeled in this is nanotesla magnetic flux density. Earth's geomagnetic moment from the ground in terms of changes to Earth's B field, geospace delta B, the other geospace magnetosphere movie. Only mild magnetic pulses here from this high-speed coronal hole wind stream. Next, we're going to show you a solar system forecast. Let me press refresh. So there's where things are now, and let's advance this to show the 1-week forecast. As Venus is swinging past, we're seeing a crescent waxing to start off the new year. Next, a star chart. If you're up before dawn, you may see Mars and the Moon rising ahead of the Sun. And the Sun's just about to pass the galactic plane here over Lehigh Valley, Pennsylvania. That blue line's the galactic plane, the yellow line is the ecliptic. And if you're wondering what that is, that's in-the-sky.org's all sky chart. Put in your location, build your own sky chart if you want to know what's going on above your head. Maybe you're interested in where Deneb is located at the moment. That's where it is, the tail of the swan, the brightest intrinsic object visible from our solar system. Speaking of solar system, let's take a look at the viewpoint from stereo A and the LASCO C3 to show a stealthy coronal mass ejection. This one looks like it may have some very minor diffuse earthly component. You can see over here on the stereo A view a bunch of ejecta there coming out of the sun all at the same time, basically. And some of that is earthly directed, as Earth is off in this direction from the viewpoint of stereo A. What a crappy looking arrow. All right, there we go. There's a better arrow for you. So again, it looks like there is some earthly component there, because when we look at the LASCO C3, and I would note the time and date stamps, we do see some ejecta here on both sides of the coronagraph. So again, those spacecraft are located at L5 and L1, stereo A at L5, LASCO C3 at L1, in between Earth and Sun. And I think there is some earthly ejecta there, although from this view it looks like it's very diffuse. So if we do see an impact from that, it'll be minor, and it might not be detectable at all, as it could occur during a coronal hole wind stream, which could entirely cancel out the coronal mass ejection strike in terms of measuring it at the ACE and Discover, which are the spacecraft that measure the solar wind out here at Lagrange Point 1. Make sure you check out our cosmology segment today. It'll premiere after the daily space weather video. You can find our playlists over at youtube.com/smAsho/playlists. And thanks to everybody who enjoys our cosmology segments. Please share with your friends and foes. Next, we're looking at charging hazards, and we see some. north of the equator in the Pacific Ocean. Moving into the western Pacific here, some minor charging hazards here on the surface of geosynchronous equatorial satellites. Here's the 1-year chart of the relativistic electrons. Here's the 3-day chart measured by the GOES 16 and 17. And we're seeing another characteristic dip in the electron flux with the arrival of the high-speed portion of the coronal hole wind stream. Here's the forecast model. And I have no reason to argue with that. Let's continue on to show the total electron content forecast, which will be the electron content between a geosynchronous satellite and your ground-based handset. Here it is. Quite a bit of chaos continues in the Earth's inner Van Allen belt. So if you see red blobs above your head on this, you can expect GPS errors of thousands of miles. They're most likely to occur around the equator at noon. I'm going to let it play through a second time as we're seeing huge chaos here. Errors, huge GPS errors likely to occur at nighttime here. Huge GPS errors over North America despite it being winter. Also some over the Southern Ocean and around Antarctica and so forth. Next we're going to show you the ionosphere since it's related. Located about 300 kilometers of altitude. Here is the vibrational frequency going on in that slice of the atmosphere, the F ionosphere layer. Each color blob represents 1 megahertz, which is a megahertz is 1,000,000 vibrations per second. Similar to the number of calculations measured in a computer megahertz. Millions of calculations per second, millions of vibrations per second is a megahertz. Next, the anomaly gram. This is anomaly in megahertz from the 30-day median. And we're seeing quite significant anomalies here. More in the southern hemisphere than the north. Once again, areas around the Drake Passage here, some wild swings of low to high frequency anomalies. And we'll bring up the latest image on this. There's 1415 universal time ionogram, and there's 1415 universal time anomalygram. And let's do bonus features. And bonus feature number 1 is the Cerro Tololo ground-based solar observatory located in, well, Cerro Tololo, Chile. Check out the filament down here. Coronal mass ejection warning remains in place, folks. There are going to be additional coronal mass ejections on the earthly side of this star. This star right here, the one depicted in the GOES 16 SUVI imagery, we'll probably stream this throughout the day today on the Twitch channel, twitch.tv/smAsho. Here is your most recent intensitygram and colorized magnetogram. And you can see Sunspot 2916. Looks like it's gaining additional umbrae there. So as it gains complexity, the likelihood of a major flare from it goes up. It's not shrinking. That's only an alpha class sunspot at the moment. Unlikely to produce major flares. And we do still have some sunspots in the north. Quite a few umbrae here, so this could produce a significant flare, and so could this. Here are the fields. There's 2916. And these sunspots have underperformed, so from a base statistical probability perspective, they are still likely to produce major flares. Here's the southern hemisphere in 171 angstroms. And we'll close out in the north. Thanks for tuning in. Congratulations on realizing the channel exists. And may that solar wind be at your back. Opinions expressed in this video, not necessarily the opinions of Smash News Network, least busted, name and news.